Let's go over activity number 4 together. So the first problem says my function is a continuous function at the point of -1. So it clearly means your function value exists and also your function limit exists at the point of -1. Function value exists is quite obvious, but in order to make the limit exist at the point, you need to have left and right side matching with each other. So in other words, limit x equals -1, and the left and right limit at the point -1 should match with each other. So it's limit x approaches -1. The left side, you are less than -1, 3x plus a, and its limit x approaches -1. So we have 2x minus a here. In other words, 3 times -1 plus a and 2 times -1 minus a. It's -3 plus a equals -2 minus a. So 2a is 1, so a is 1/2. So those 2 points technically could have been 1/2, and it's going to be a continuous function. The rest part is asking you to verify all discontinuous points and justify your conclusion. So my first idea is to go over wherever the denominator is 0 and wherever my function was cut into 2 pieces. So the potential points were -1, 3, and 2x minus 7 being 0, so x is 7/2, or 2x plus 7, 0, so x is -7/2. Those are my potential solutions. Clearly, I'm not going to use the first one because I've already have it verified it's continuous. I don't know what's going on with 3. We need to double check. At the point of 7/2 to 3.5, it's definitely making my denominator to be 0, so function value doesn't exist. At the point of -7/2, I realize I need to use the first row to evaluate my function, so that doesn't work. So all I have to do is to check what's going on here and show that that's a not continuous point. At the point x being 7/2, I realize my function x, f of 7/2 is 7/2 squared divided by 2 times 7/2 minus 7, and 2 times 7/2 plus 7, which we end up with 49/4 divided by 0. This function value does not exist. So it is not continuous because it violates the first item in the continuity checklist. And the second part is at the point x being 3. It's where the function were cut into 2 pieces. You will realize f of 3, which is 2 times 3 minus 1/2, which is 6 minus 1/2, which is 11/2. If you want to find the limit, you need to separate on both sides. So you have limit x approaches 3 plus, so it's greater than 3, it's x squared over 2x minus 7 and 2x plus 7, which is 9 over -1. 2 times 3, which is 6, which is 13. So we end up with -9/13. And then we have limit x approaches 3 minus f of x. This limit x approaches 3 negative, so we end up with 2x minus 1/2, so we have 6 minus 1/2, which is 11/2. It's quite obvious that those two numbers does not equal to each other, so limit x approaches 3, f of x does not exist. So those are my two final answers. First one, at the point of 1/3, it's not continuous because the limit does not exist. At the point of 7/2, my function value does not exist, so those are the 2 points where my function are not continuous. And let me highlight my previous answer as well. So I want to choose the type of discontinuity. The type of discontinuity came from the second case at x being 3. Your left and right limit doesn't match. It's that one side limit exists, but they are not equal to each other, so that is a jump. At the point of 7/2, you end up with something to be non-zero over 0. We said if it were a limit problem, that means it blows up to infinity. So this is a type of infinite type of discontinuity, right? So one or both sides of the limit goes to infinity. So when you do substitution, you realize it's non-zero over 0 type technically, and that's lead to infinite discontinuity. So let's continue the rest part. We want to evaluate limit problems, and I say the intuitive idea is always by substitution. You don't have to simplify, so either step would be accepted as final answer. So what I end up with is sine of 3 times 2 minus 1, and it's e to the 1 squared, right? Of course, you could always simplify them, so you end up with that. You have cosine of 0 over 0 plus 1, and it is 1. This is minus 2 times 1 over cosine 1, which is 0. This is 2 minus 2 times pi over 2 over cosine of pi over 2, which is 2 minus pi over 0, so it does not exist. So my final answers were expressions like that. Okay, so evaluate the following limit problems directly if possible. So you want to do substitution, you will have 1 squared minus 1 and 1 squared minus 2 plus 1, so it's a 0 over 0 type. So it's limit x approaches 1, x minus 1, x plus 1. This is x minus 1 times x minus 1. Limit x approaches 1, so we end up with x plus 1, x minus 1. You realize after substitution, it is 2 over 0. It is non-zero over the 0 type, which means the limit does not exist. The next thing is 2 times 2 squared minus 2 minus 6, 2 squared minus 4. So we end up with 8 minus 2 minus 6. We have 4 minus 4, 0 over 0. So we have limit x approaches 2, 0 over 0 type. It's always a good idea to factor it. So we have 2x, we have x, and then we end up with 3 and 1, and then we have minus and plus. So once you factor it, what we have after the cancellation, let me double check, my bad, this is 2 here. So we have 2x plus 1 over x plus 2. So we end up with 2 times 2 plus 3, 2 plus 2, so we end up with 7 over 4 as my final answer. The next problem, 1 squared plus 2 minus 3 over 1 minus 1, so it's 0 over 0 type of problem. So again, it's about cancellation, so we end up with x plus 3, x minus 1, almost over x plus 1, x minus 1. So we end up x approaches 1, x plus 3 over x plus 1. 1 plus 3, 1 plus 1, which is over 2, which is 2. So we have my final solution for those 3 problems. Last but not least, I want you to evaluate the limit problem we have here. I want to see what's going on when I'm approaching to 1. So technically, I'm trying to observe what's going on. I'm approaching to this. As you can tell, I have contradicting information, both of which approaches infinity. So this does not exist as my final answer.